All right, so today I'm gonna be giving you an example of a moment rotating at a certain, if my camera will focus. All right, I'll be giving you a moment problem rotating at one moment. The problem is saying what counteracting moment must be applied at moment A to keep moment B at equilibrium. We really don't care what any of these moments are. We don't care what they are, to be honest. Um, we only need to know what moment B equals. That's the only thing we need to know because it says at equilibrium. So we must calculate what moment B is. And it really doesn't matter what any of this is. We just need to know we need to know what the value of moment B is. All right. Okay, so let's get started. So let's take a look. Let me sit down real quick. So let's get started. We're gonna look at each component or each moment and see what components, how many components they have. And I'll let you know how to figure that out. So at moment A, it is in line with moment B and it's only in the y-axis. There's no distance in the x-axis. So this only has one component. So this is only in the y-axis. And as you get good at and get more familiar with moments, you'll be able to pick up on this a lot quicker. So at moment A, let's take a look here. It's 8 meters above. It has a force of 200 newtons. Let's take a look at this slope, or not the slope, but this triangle here. We do know that we're gonna need this value here. And this is simple. This is a squared plus b squared equals c squared. So 4 squared is 16, 3 squared is 9, 16 plus 9 is 25. You take the square root of that, you'll get 5. So this would be 5 here. So we're only looking in the x-axis, or not the x-axis, but the y-axis for A. So we'll take 200 meters, or 200 newtons, I'm a little tired. 200 newtons, and then we need to know this point is going to be right here. So this 200 newtons is right here. I'm going to give you something that I learned a long time ago. So this would be some old hippie caught another hippie tripping on acid. And if this does not ring a bell to you, this is from trigonometry. So sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over hypotenuse. Where this comes in handy is, so sine y, that would be in your y-axis, cosine is in your x-axis. What we really care about are these right here. This is what we care about. We care about these. So let's go back here. Let's take a look at this. So we care about the y-axis. We care about sine. So looking here, we need to find opposite over hypotenuse. So if we're saying that this is up here at this point, this force is at this point here, the opposite is going to be 4. Hypotenuse is going to be 5. So now we look here. This would be the 4 over 5. And we have a distance above the moment B at 8 meters. And also, if we take a look, we're going to make clockwise positive, because this is the way that this moment is going. It's rotating in a clockwise manner. So clockwise is positive. this force is driving. If we're gonna spin B in a clockwise fashion, this will be going with the clockwise. It'll be acting with the clockwise. So this will be a positive. This will be positive, okay? So this moment will be positive. Now let's take a look at moment B. All right, they give us this right here. They give us this. So we'll do 700 Newton meters, okay? So this is a given. Let's take a look at moment C, okay? So moment C, it says it has one at 150 driving here. We got another one at 150 driving down. Regardless of what it is, it's gonna be 150, okay? This is gonna be 150 driving down. All right, so 150, and then we have a distance of 4. There's no slope here. There's no slope. There's only, it's in line with B. So we only have one component, and that is the x-axis, okay? With there not being a slope, we do not need any of this right here. So we don't have to deal with any triangles here. So this would be 150. Newtons with a distance of 4 meters from this moment. And if you already know, if you know this is going to be positive, give yourself a pat on the back, because this is certainly positive, because it's going to be going in the direction of that moment spinning at clockwise. So this would be positive. Now, moment D is where things get a little tricky, okay? Moment D, you got to look at your x-axis. So it has a distance in the x-axis of 4 meters. And it also has a distance in the y-axis of 2 meters from moment B. So you have both X and Y. So you have to break those into 2 components. So this would be X-axis and Y-axis. We'll take care of the X-axis first. Okay. So for the X-axis, put this down here. All right. So X-axis, we know that we need adjacent over hypotenuse. Okay. So coming back up here, we do know that a squared plus b squared equals c squared. So 12 squared plus 5 squared is going to be 169. 169, take the square root of that, it'll give you 13. All right, so it's 13. So we know up here at this point, across here is going to be what? It's going to be your O. Right here is your A. This right here is your H. Okay, excuse me. Let's take a look. So your A over your H. And we know that this is in, this force is 300. Then we just got our I'm lost for words. You got your adjacent and your hypotenuse. So we got the 12, it'd be 12 over 13. 12 over 13 at a distance. This is x-axis. We're looking at x-axis. So we got that. We look at here. This would be 4 meters. So 4 meters. Okay. Now let's take a look at y-axis. So we know our force is 300. Let's take a look at what the y-axis would be calling for. And we care about opposite and hypotenuse. So don't want y'all getting confused thinking that's a 50 there. So this would be your hypotenuse, which is 5. And your opposite, which is 5, and your hypotenuse is 13. So again, we got that from some old hippie. So be 5/13. And what is that distance in the y-axis? Is 2. So that'll be 2 meters. Okay. We now have accounted for all of the moments that we need. So let's take a look here. Let's take a look here. We're gonna look at moment D because I forgot to give y'all valuable information there. All right, so let's take a look here. This moment has a force acting. It's going to be acting against this moment. If I'm spinning this whole figure, this will be going with it. This would be going with it. This right here would be acting against it. So these two components are going to be negative. So this would be negative and this would be negative. All right. So now that we have everything accounted for, let's take a look and do the summation about moment B. So the summation about moment B, we're going to take a look. This would be, we're just going to take all of these and add them together or do the summation of it. Okay. So it'd be 700 Newton meters plus 200 newtons, 4/5, with a distance of 8 meters that we took care of earlier. And then we have the moment C here, which was 150 newtons with a distance of 4 meters. And then we have our two components from moment D, -300, 12/13, with a distance of 4 meters, and another -300. I need to put something on my paper. It's sliding. All right. And that was 5/13 with a distance of 2 meters. Okay. Now, if you take this and plug everything into the calculator, which I'll do that with you right now. All right, so 700 plus 200. Press the wrong button. 700 plus 200, 4/5. With a distance of 8, plus 150 with a distance of 4, plus, or minus, minus 300 with that slope of 12/13 with a distance of 4, minus 300 with that slope of 5/13 with a distance of 2. Now, if we plug this into the calculator, we get an answer of 1,241. All righty. And that'll be Newton meters. So 41.5 for Newton meters. This would be what you need at, let me move this. This would be what you need at moment B or moment A or any of these moments in order to be in equilibrium with B. The moment that it said equilibrium with B, we knew that we only needed to calculate what moment B would be, or the moment about B. Yeah. So if y'all have any questions about this or need some help on anything, just leave me a comment, leave me a like, subscribe to me. I'll be dropping videos as I'm studying for my FE, and this helps me remember some of the things that seem to have forgotten while I was in engineering school. So thank you for watching.